Course 2, C.Notes, solving one-step equations. In our learning target for this lesson, we are going to model and solve one-step equations, and we are all going to be showing our answer on a number line. Okay, so we're modeling, solving, and showing our answer on a number line. And this should be review at this point, but we want to make sure everybody has a firm foundation. Okay, so first one, example. We are going to use the same example throughout the lesson, but the first one we're going to solve using a model. So we have x plus 3 equals 5. So if you guys remember from last year, this should be a review. So I'm going to say that x we're going to represent with just this long gray rectangle. And then 3 positives, I'm going to have 3 gray circles that are filled in. If they were negatives, then I would have them being just blank empty circles. So we have 1x because we have 1 gray rectangle, and then we have 3 filled circles, and this equals 5 filled circles. So if we want to solve this using a model, we're still going to use inverse operations or opposite operations. And our goal here is to get x completely alone. So if we want to get x completely alone, we have to get rid of this plus 3. So we have to get rid of these 3 circles that are filled in. So in order to get rid of the 3 circles that are filled in, we're going to add 3 empty circles. And that's going to create a 0 pair, which cancel each other out. So now we have no more of the positive 3's. But since it's an equation, if we do something to the left side, well, I also have to add 3 empty circles to the right side. So that also creates some 0 pairs. Okay, but if you notice on the right side, all of the circles are not gone. So now we look, what do we have left on the left side here? Well, we have 1 rectangle. And then on the right side, we have 2 closed circles. So our answer, x equals 2. So that's how we solve using a model. In this case, we used for our x, our rectangles, and then for our positives, our closed circles, and for our negatives, our open circles. Okay, so now we're going to do another example. We're going to use exactly the same equations, but we're going to solve using algebra. So not using a model, just using our numbers. So we have the same example, x plus 3 equals 5, and to show this with algebra, we still want x alone. So to get rid of our plus 3, we have to subtract 3. If you put your finger on the number line, to get back to 0, you have to take 3 away. So we're going to subtract 3. So 3 minus 3 is 0, so that cancels out. If I subtract 3 from the left, I have to do the same on the right. And then I have left x equals 2. Is that what we got before? Absolutely. The only difference, we're showing our strategies and our thought process in different ways. The first way we showed using models and visuals, and the second way we showed using algebra and numbers. So to check our answer, since we got x equals 2, we're going to take the 2 and put the 2 instead of x, since x is 2, we're going to take 2 and put it in for x, plus 3, and see if it equals 5. 2 plus 3 is 5. 5 does equals 5. Check. We're good to go. If we did that and got something else, then we did something wrong. So we'd have to go back and revisit. Okay, and again, this is just review. We're just building a firm foundation on where we're headed. But the last thing that we want to do, our answer has been x equals 2, and we want to be able to express that on a number line. Okay, so here's my number line, and here's 0. If you move to the left, and we all have number lines, those are our negatives. And then if we move to the right, these are our positives. So our answer that we got using models and algebra was x equals 2. So we're just going to put a closed circle at x equals 2 on our number line because that's showing our solution. Okay, we're shading and filling in our solutions. So that's it. Very short lesson. I would like everybody to write your summary of solving one-step equations. Again, learning target, we solved using modeling, algebra, and showing our solution on a number line.